Hello dear students, our next derivation number 12, electric potential energy of a system of 2-point charges which are kept in a uniform electric field. This is not a derivation as such, but since it is part of NCERT and you never know what things can come in exam, from a derivation perspective, I don't think it is really important, but it is important from exam point of view because often this is a small portion and it gets lost in the complete chapter. Sometimes students and also the teachers I have seen they tend to ignore this topic. And the last year board exam, CBSE, they picked up this topic only and they created a good problem. Right? This problem was taken from S.C. Verma, but this uses this concept only which we are talking about. Okay, so how will we calculate the electrostatic potential energy of a system of two charges? Forget about electric field. We have already learned system of two charges Q1, Q2 kept at a distance R. The potential energy is nothing but 1 upon 4 pi epsilon naught Q1 Q2 by R. Right, so R12. That is the R12 means this distance, right, from 1 to 2. So Q1 Q2 upon R12. Right, this is something we already know. Now, in addition to this energy, now this charge are not isolated. Right now, they are present in an electric field. So if you go back to our previous discussion, when we derived the formula for 2-point charge system 1 upon 4 pi epsilon naught Q1 Q2 by R, when we brought Q2 from infinity to a point, we said the work done is 0. Now that work done will not be 0 because there are already an existing electric field existing. So because of this electric field, there will be some electric potential at this point A. Now electric field might be uniform, but you know that electric potential is a space function. It changes with point to point, right? In a uniform electric field also it can change. So at this point, let's say the potential is V1, and this point, let's say the potential is V2. So your work done in bringing Q1 from infinity to this point will be Q into V. So Q1 into VR1. VR1 means potential at this point which has a position vector R1. Q1 into VR1 means nothing but you're just doing Q into V. Why we are writing VR1 instead of V? Because it is changing. VR1 here, VR2 here. That's the reason we have put Q1 into VR1. Similarly, when you bring Q2, this work you will have to do against the electrostatic force of this charge. But also you have to do the same work, equivalent work against the electric field also. So Q2 into VR2, V into Q. So these two components are coming because of the existing electric field, and this component is coming because of the mutual repulsion or attraction, whatever be the case. This component is representing that part, and these two components are coming from the point that they are being brought in a uniform electric field. So you have to do some extra work. So this is Q, V into Q for 1, V into Q for 1. Very simple. But more important is this construct, right? That in a uniform electric field, when the charges are kept in a uniform electric field, the electrostatic potential energy will not be just this. It will be addition of this plus this plus this. If you want to learn this concept, take my advice. NCERT has given a very good example. There are examples in SC Verma also, but you can refer to NCERT because not many students might be having SC Verma. So NCERT में आप टेक्स्ट में एग्जाम्पल 2.5 को ABC 3 पार्ट हैं, तीनों को फॉलो कीजिए. You will be able to understand this concept completely. Remember, this was asked in the board exam. I'm not talking about JEE Mains or JEE Advanced. This was asked in the board exams, right? So do not miss this example, right? मैंने क्लास में ये डिस्कस किया था, राइट? मैंने होमवर्क भी दिया था आपको ये क्वेश्चन दोबारा करने के लिए, बट अगर आपने तब भी नहीं किया तो अब आपके पास मौका है, इसका दोबारा कीजिए. प्लीज डू नॉट लीव दिस. थैंक यू वेरी मच.